Google's Gemini 3 DeepThink is here, advancing science, research, and engineering. Our most specialized reasoning mode is now updated to solve modern science, research, and engineering challenges. Guys, Google Gemini 3 DeepThink is here. I'm not sure why this isn't really being talked about much or why Google didn't do like a big release on it, because this is by far in advance the smartest model that's available today. The implications this is going to have specifically in the scientific community in terms of mathematics, physics, pharmaceuticals, any kind of science that we do is going to be, it's literally going to change everything. Gemini 3 DeepThink was built to push the frontier of intelligence to solve modern challenges across science, research, and engineering. What this is going to do in terms of people working in the science fields to work alongside a tool like this to help it in their research. I'm going to play you a couple clips of people that are using it right now.
I've been using AI in my research. It really has the potential to accelerate discoveries. My research work in infinite dimensional algebra and symmetry is really a tool for the high-energy theoretical physics community, looking to combine Einstein's theory of gravity with quantum mechanics. I was working on a paper with a colleague, which took several years to prepare. Before sending it out to the journal, I decided to put it through Gemini for fact-checking and verification. It came straight back with, "No, that's not correct. Proposition 4.2 is mathematically incorrect as stated." It gave 3 separate irrefutable reasons why our mathematical arguments around one particular statement were incompatible. This was pretty destabilizing because the paper had already been peer-reviewed. I debated, and the model didn't try to appease me, as most AI models do by trying to guess what you want to hear. It took me a while to understand because it was really outside of my thought process, and the model's reasoning was completely correct. The paper's at the forefront of research in the subject, and so there's very little context or training data that the model could have been trained on. So it seemed as if it did the work of a highly trained mathematician. It helped us realize that we didn't need the full claim of that result and that a simpler result was actually true. Once we have a unified theory of all the forces of nature, it'll completely change our understanding of ourselves and of the universe.
I love how it was just like, no, you're wrong. I mean, but do you see, guys, how this is a game changer? I mean, obviously humans for now still need to be like a creative force thinking of like new ideas, what to work on and things like that. But having like a superhuman fact checker right alongside us in your, like as an assistant in your pocket, basically at all times is obviously a game changer for people at the highest levels, because they're working on these complex things. As she said, she thought she had all these things figured out. So she said, "Oh, I'll just put it in here, double check." And it's like, no, you're wrong. And it showed its work of why it's wrong. But what's even more interesting is that it had a like what she said, it was stuff that it wasn't even trained on. Like, it wasn't trained on the math problems that she was working on, but it was able to figure it out based on the intelligence it has. That's the level of this deep think, which is basically Google's most advanced model they've ever made. It just thinks longer, harder, deeper for with more reasoning than any other model to date. And I'm going to show you some benchmarks in a second, but it's really crazy to see what people are working on right now and how they're using it. In this video, this guy is building chips and he talks about how he's using it in his lab.
In my lab, we use DeepThink to design new semiconductors. We found that the result is awesome. We want to grow a 100 micron size of 2D semiconductor. Using the DeepThink suggested recipe, we got the size of 130 micron. That's the best result ever in our lab. As silicon reaching its theoretical limit, my lab using DeepThink is working with new materials in the 2D space. Two-dimensional material is a family of material that has one molecular thickness. It's a natural choice for futuristic electronics because its thickness is extremely small. So growing two-dimensional materials is challenging. The challenge is how we choose the parameters. You have to tune the gas flow, and also we are using furnace to heat it up. It takes the expert weeks or even months to find the sweet spot in the parameter. DeepThink not just give a temperature number, but give a whole thermal profile. It's accumulated the recent advances in science. I feel that I'm very excited. This is just the beginning. DeepThink API opens a new door to automate many of the counting instruments.
Couple things to know from that video. Think of what he said there. He said, we had our best result ever, And this is obviously a smart guy. He works in this lab all the time. He's an expert in this field. This is all he works on. This is all he does. And with this little boost from the DeepThink, he had his best result that he ever had. That's number one. Number two, he talked about, finding that perfect sweet spot for the temperatures and the things for some of the testing that they do with the certain things that they work on. And then he said that, Gemini DeepThink was able to find those variables, quickly. What would take them weeks or, possibly longer to work on, it can find those just in maybe hours or days or just a significantly less time because, the computer can just think nonstop, very high speeds, very quickly, 24 hours a day if it needs to really go deep on those problems, which obviously even the smartest people in the world still need to sleep and take breaks and eat and all that stuff. And they get tired. And then also at the end, how he said, and remember, this is just the beginning. And this is what I always think about every time one of these new breakthroughs comes out. It's like, man, where are we going to be in a year or two? Like science is about to explode. And I realize that AI has a lot of scary things about it, like in terms of like our jobs and, it's going to reshape entire way of life in many ways, good and bad. But in terms of science and research, I can't help but be super excited when I'm watching videos and learning about new tools like this that are specifically helpful to people in the scientific communities, because that's how we get all of our advancements in life, like in terms of science and medicine and math and physics understanding and new materials and things like that, that pretty much make life better. In this last video that I'm going to play for you here, before I talk about some of the benchmarks, which are absolutely insane, this guy's talking about, he builds like things that help people with disabilities, and he kind of goes over how he can go through more iterations faster because you can use tools like Gemini DeepThink to, come up with new ideas, not new ideas, but like like modelings for the hardware. I'll let him explain.
I just love building things. I was one of those kids that just was always taking things apart. And then I quickly kind of realized that you can do that to help people. The power of good design is you can transform the world and you can transform other people's lives for the better. Using Gemini and DeepThink mode, we're now able to design and iterate faster than ever before. This is one of the products that we had when we were a startup. This was designed for people with cerebral palsy or spinal cord injuries. I've been focusing a lot in the last year on how we can enable DeepThink to actually help make the design process 10 times faster. I can just send an image or send a prompt, and it's able to actually think through and then come up with several candidate options for us, new designs that we hadn't even thought about before. One thing we did was try to challenge the model. I gave it an image of a turbine blade. And so it came up with a design, and then I was actually able to talk to the model to change the pitch of the blades and even the shape. I myself am not a CAD designer, so I would not have known how to make that. The AI tools we see today, I see them more as accelerants, and that's what makes me really optimistic and hopeful. We can rapidly explore different material options, focus on research questions and technologies that don't exist today. There's many, many problems in this world still, and there's huge opportunities for us to make things better and get products to market much faster.
I love what he said there, and that's how I'm starting to think about it, at least at this time. Are we at a point where AI is going to come up with new ideas, like where AI will just start saying, hey, you guys should make this, you guys should do this? Not yet. I think probably we will reach that point at a certain point, but right now, human beings still have to decide what should we work on, what should we focus on? And then, like he said, his exact words is, it's an accelerant, right? Like we are burning the fire, and this AI is just like, here's some gasoline, like it's about to so that's how I'm perceiving the scientific fields going from here. All right, now let's really blow your mind. I'm about to go crazy with these new benchmarks because these are absolutely insane, and it's crazy why Google isn't really like didn't have like a big rollout with this and talk about it much. So new standard 48.4% on humanity's last exam with no tools. 84.6% on ARC-AGI 2. Staggering ELO of 34.55 on code forces for competitive programming challenges, and then gold medal level performance on the International Math Olympiad 2025. So look at some of these benchmarks. ARC-AGI 2 is basically a test to see how they do puzzles and things they've never seen before. So that's why it's called AGI, because it's like general intelligence of like, if like a human never saw something before, we would still kind of have a good idea how to handle it. Right? Like you could come into a situation that you've never been in before and you can still figure it out because you have a lot of ways of reasoning and thinking of past experiences and things like that, right? So that's like a test that they put things through, because a lot of the earlier models used to only be good at things they were trained on. So like if it was trained in this specific thing, it would dominate that thing, but showed something it's never seen before. And it was like, I don't know how to do that. So ARC-AGI 2 was a test to basically test the models on things they've never seen, how they can reason through problems that they weren't trained on. So it's supposed to be very hard. And even our smartest models, like we've had things come out like this is ChatGPT 5.2. This is a recent model, Claude Opus 4.5. Like these models are beasts. And look at what this new DeepThink did. It crushed theirs. And this is Gemini 3 Pro right here. So and this only came out a few months ago. So then they made this leap in ARC-AGI 2. I mean, it's getting close to 100% at this point. I mean, when will we be at 100% on ARC-AGI 2? Honestly, at this pace, a year, 2 max. I mean, I don't see how it could take any longer to where it can solve any problem that it's never seen before, for the most part. Humanity's Last Exam was, if you don't know what that is, it's basically a test that was made to be the hardest test humans could ever make. Like the smartest humans in the world would get like a 1% or 2% on this, because only humans can be experts at so many things, right? Like you can be an expert in math, you can be an expert in physics, you can be an expert in biology or something, but you can't be experts in all of those things. Even the smartest people in the world only know pretty much about one thing. So, or maybe a couple at most. But these computers, obviously, they can have an expertise in the law and in medicine and biology and physics and math and all of these things. But it's still such a hard test, because they basically, what they did is they took experts from all these fields and they said, give us your hardest questions that you could even possibly think to ask someone about your field. And then what they did is they took in like a large volume of those questions and they whittled it down to the hardest ones. And then, so they have like the hardest of the hard, and it's in all these fields. That's why I said even the smartest humans on the planet could get like a small percentage, like 1% or 2% of the questions correct. So this is why it's Humanity's Last Exam. It's the hardest test we can ever make. Like humans can never create a test harder than this test in terms of like just, asking questions. So, pass it models were getting like 12%, 24%. Recently, we started cracking 30s, 40s, and now Gemini DeepThink with no tools. By the way, that means it can't use search, can't use any other assistance in any way, which obviously in the real world, AIs will be able to use tools. It'll be able to use assistance. So it'll be doing way better than that. But 48.4% absolutely crushes the other models, crushes Gemini 3 Pro, crushes Claude Opus and GPT 5.2. So, it won't be long till this keeps saturating as well, probably another year or two. Understanding reasoning, it's basically the best. Code forces, this one is absolute monster. So ELO score is basically like, some people might know it from chess. So basically in chess, ELO score is measured to see how good of a chess player you are, because it not only measures how good, like how many wins you have, but it also factors in, how well you did against other chess players, how good they are. Like if you beat a bad player, your score might only go up a little bit, but if you beat a good player, your score goes up a lot more. So it's kind of like a complicated measure. But that's basically all you need to understand about it. But look, Gemini 3 and Claude Opus, which are, two of the best coding models that were out like as of last week. And look at what Gemini 3 DeepThink did on code forces. Like this number is inhuman. Like this rivals like the top humans. Like it's close to the top humans. Oh, make it a little bigger. Okay, this rivals close to the top humans. This number is like inhuman. Like no human can ever really reach this. And like I always say in every video, it's just getting started. So this number is absolutely insane. I mean, the level of coding that we're getting to is unreasonable. So just to put a pin on these benchmarks. So you talk about ARC-AGI, like look at this 84.6 compared to 31, just in Gemini 3 Pro, Claude Opus, GPT 5.2, Humanity's Last Exam, crushing it. If you give it some tools, it goes up to 53.4. The Math Olympiad, 81.5 compared to 14.3% with Gemini 3 Pro, and it beats Gemini 5.2. Code forces we talked about. International physics, 87.7%. That's higher than all the other 3 top models. And the International Chemistry Olympiad 2025, 82.8%. That's higher than Gemini 3 Pro and GPT 5.2. So really, guys, it's accelerating real world engineering. So there's a lot of models out there that do a lot of things. There's things that are great for coding, great for video, great for writing text, great for a lot of things. This model can probably do a lot of things, but in terms of deep thinking and reasoning, which is what you need in terms of like scientific advancement, this is built to drive practical applications, enabling research to interpret complex data and engineers the model physics systems through code. Most importantly, we are working to bring DeepThink to researchers and practitioners where they need it most.